Good day, everyone. So today we shall be diving into introduction to oblique drawing. Oblique drawing is a fundamental technique in technical illustration. It's one of the important technique of drawing in in engineering. Okay, and is actually a technique that involves representing a three-dimensional shape in a two-dimensional plane. All right, and now let's see how this works. So firstly, I would like us to talk about the definition of oblique drawing. So when we say oblique drawing is actually a technique in drawing that involves drawing the true proportion of the front face of the object, the true proportion of the front of the object, and also simplifying the side by receding the side of that object into an angle of 45 degrees without straight perspective. So it's a technique that involves drawing an object whose front is exactly the same proportion, but the side is receded to angle 45 degrees. As you can see this box here, this box, the front of this box is actually the true proportion of the box, but the side of the box has been receded to an angle of what, 45 degrees. You see now. So with this type of technique of drawing, it make it it make it easy to convey the information of the object. Okay, it gives quick information of the object that is being drawn. That is what oblique drawing is about. A technique that involves drawing the front face of an object in its true proportion and also drawing its side part receding at an angle 45 degrees. Now, the key angle in oblique drawing are just two: the angle 90 degrees and the angle 45 degrees. All right. Now, the angle 90 degrees is used for the vertical and horizontal line of the front face. You see the front face here now. So this is the angle 90 degree here. This line and this line are form 90 degree. So we use it to draw the front face of the object, while the angle 45 degree is applied to a line indicating the depth of that object, receding away from the viewer to create the illusion of three dimensions. So this is the depth of this box. So the angle 45 degree allows us to be able to view the depth of the box. And with this now you can see the side view of the box, the front view, and the top view, which give us the illusion of three dimensions. Alright. So now there are two types of oblique drawing actually. We have the cavalier oblique and we have the cabinet oblique. Okay. The common the similarity between these two oblique type is that they are both receding at angle 45 degree here. This is the cavalier one. This is a cavalier oblique drawing, but it's receding at angle 45 degree. For the cabinet, it's also receding at angle 45 degree. So they have that similarity of having receding angle of 45 degree. But then what is the difference? Now, when we talk about cavalier oblique drawing, all the three axes use the same scale. In other words, the depth, okay, the height and the length have the same scale. Okay, so we can see the depth is full scale, the height is full scale, and the length is full scale. So the three are full scale. On the other hand, when you talk about the cabinet oblique, there is a little difference here, and that difference is the depth. The depth dimension is reduced to half of the scale. Unlike the cavalier, where we have full scale for the depth, full scale for the height, and the full scale for the length. For the cabinet, the depth is reduced to half. It's reduced to half of the dimension of that object. That is different. So it has full scale of height, that full scale of length, but the depth is half of the original dimension. So that's the difference between the Cavalier oblique and the cabinet oblique. Right? Now, let's talk about the symmetry and the center line. This is another type of oblique drawing. Now, the center line helps us to, help us to recognize or identify rather the symmetry in an object drawn in oblique form. Okay, center lines are actually lines that are shown with chain dotted lines. Okay, you can see this cross here now is a center line. Okay, and they are crucial for symmetric objects. What they indicate is the center of circles and holes. Now this center line here now, the two of them has indicated the center of this circle, as it has indicated the center of this other circle here. Now they also help us to, the horizontal part of the center line help us to divide the object into its symmetry. Okay, now when we say symmetry, into equal halves. So the horizontal center line helps in dividing an oblique object into equal half. So the center line plays important role, and that one of the major roles is to help us to indicate the center of circles or the center of holes. Aside that, we also use the center line for dimensioning. Now, if you want to put dimension, that means when we talk about dimension, we know we want to put the length, the measurement value. Now, it is best to use the center line when we are writing our dimension. You could see here now that these are dimension lines, and then the length of each part of this object is indicated using the dimension line. Like where you have this 17 here, you see dimension line indicating it. It is being written directly on the center line. This 33 as well, from this center line down to the other side. So when we are dimensioning our object, we should directly write it on the center line. Okay, so this method will provide greater clarity compared to dimensioning solely between surfaces. When the dimensions are just between surfaces, the viewer might not be able to understand where the dimension belongs. But as you could see here now, following these center lines here and then writing the dimension, it will be easy to understand that this 45 here is between this point here and this point. All right, and then when writing measurement in oblique drawing, only numbers should be displayed. The unit should not be there. You can see this 45 is not having a unit. None of these numbers here have no unit, and they actually dimension. It is not indicated whether it is 45 millimeters or 45 meters or so on. But then the rule is that only the number should be written. However, the unit should be stated somewhere on that drawing, as it is stated here now. All measurement in millimeters. So you state at the bottom of the drawing what the unit is, but in the main drawing, just put the numbers. Okay, so do not put the unit on the main drawing when dimensioning, and let the center line be used in determining or writing the dimension of the object. Right? So moving on, there is also a type of dimension we call the reference dimension. Okay? For reference dimension, they are marked as ref. Okay? For convenience, so you put ref. And they are not really required in an object, okay? Because they can be calculated from other dimensions. Okay, it's just for quick information. Okay, reference dimensions are just for quick information. They are not really required. And how do you know then? You see, as you see here, 60 ref. When you write it, you put ref. Some other time, you put bracket. The modern method now is put bracket between the parenthesis rather between the 60. Either you put bracket between either you write bracket in front and the back of 60, or you write ref. That makes 60 a reference dimension. And like we have said, it is not really required. It's just a kind of given information because it can be obtained. So how can we obtain reference dimension from other dimension? Very simple. As you could see here now, from here to here is 45, down to from this point here down to this place. If you check here, it's having radius of 15. 15 plus 45, that is 60. That's why we say we can obtain reference dimension from the other dimension in the shape or the object drawn. Okay. Again, another example here is 30 ref. This 30 ref, I can easily know that, okay, from here to here is 30 using this radius 15. So definitely the other radius too is 15. So the two of them sum up give us 30 ref. So just to give us an information, a quick information about the dimension. It's not to be used as our major reference, our major dimension. So the reference dimension is not strictly required for manufacturing, but it aids in understanding the overall size without redundancy. That is the importance of the reference dimension when we are drawing an oblique diagram. All right. Now, we have said it earlier before, when you are writing your dimension, okay, we should only use number. However, the unit should be indicated at the bottom, whether it's in inches or millimeters or in meters. It should be indicated at the bottom, as well as the scale. The scale of the object should also be stated. Okay, whether it's 1:1 or 1:2, should be stated also along with the dimension that we have given. All right, very, very crucial. What is the advantage of oblique drawing? Number one, oblique drawing gives us front view emphasis. If you want to emphasize on the front view of any object and you want to show it to someone, it is better you use oblique drawing in presenting that front view. So it emphasizes on front view. You could see this. That's another example of oblique drawing. You see the front view of this box, give you the real proportion of the front view of that object. Two, oblique drawing gives simple depth representation. We convey depth without the intricate rules of true perspective. If you want to get the depth of an object, like now this is the depth here, downward, you can also use oblique drawing. Another advantage is that it gives quick sketching. With oblique drawing, it can quickly gives quick sketching. It facilitates rapid technical sketch for design conceptualization. So if you want to quickly give a quick representation of your 3D shape, you can quickly use oblique drawing method. And then it gives true circles, where you have true circles to be located in the front face. Okay, oblique drawing will give you that true circle. It will not make the true circle to be bent or to be stretched in any way, to give it exactly the way it is, as long as it's in the front view of that object. All right. Now, when do we choose oblique drawing? We have already said it from the advantage here. Okay, but the major purposes for choosing oblique drawing method, okay, apart from isometric drawing in one of our lessons, is for complex front faces. In the case where the front face is complex, then it is good that you use oblique drawing to explain to present the object. Two, clarity over realism. With oblique drawing, you can get the clarity of the depth of the object, no matter how complex it may be. And it also gives quick visualization, as we said earlier, quick visualization of how the object look like. Oblique drawing will give you that understanding. So oblique drawing excels in scenarios where a clear undistorted view of the main face is crucial. Because if you want a clear view of the main face, then you combine these oblique drawing skills. Okay? All right. What are the core principles of oblique drawing? Number one, it gives us true proportion. It gives us the angle depth of that object, and it gives us the depth scales, depending on the method you are using, whether it's the cavalier oblique or the cabinet oblique drawing you are using. So it gives you the depth scale of that object, as you can see here. All right. Now, practice, they say, makes perfection. For you to draw an oblique drawing, or for you to practice this technique of oblique drawing, you need to experiment, try different objects and place it in angle 45 degree. Compare the difference between cavalier and cabinet. You have said it before. Try to draw that object and compare your objects both in cavalier view and in cabinet view. Then understand how depth scale affect appearance. You know, the depth in cavalier is different from that of the cabinet, so you have to understand it. Then review, check against established drawing convention. Ensure that you are using the correct drawing conventions in drawing your oblique diagram. So this is the end of our lesson today. I hope you have learned something about oblique drawing. Thank you for watching and have a wonderful day. Bye for now.